Hi Chem 20, Mr. Riley here. I'm going to do a quick little video on titration. A titration is an experimental process that we would use to determine the concentration of an unknown solution. So we have a solution of some type and we want to know the concentration of that. And so we can solve this using stoichiometry. But sometimes we're missing a piece of information that we need to get experimentally, and that's where the titration comes in. So here's a practice problem. We have a 10 milliliter solution of sodium hydroxide. So great, okay, so I have a 10 milliliter solution of sodium hydroxide. So 10 milliliters, that's 0.01 liters. That is going to be titrated, I'll tell you what that means in a sec, with a standard solution of 0.5 mole per liter hydrochloric acid. So I have a concentration of my hydrochloric acid here, 0.5 moles per liter. And we want to determine, from this problem, we want to determine the concentration of the sodium hydroxide. Great. Well, this looks like a solution stoichiometry problem, except I have a problem. I'm missing one piece of information that I need, and that is the volume of HCl that is required to completely react or neutralize this 10 milliliters of sodium hydroxide. So I'm going to determine that experimentally. I'm going to do an experiment to figure out what volume of HCl I need to completely react my sodium hydroxide. So I'm going to set up a titration. So this is what a titration setup would look like. So we have here a big long graduated tube that's called a burette. We have in that burette we have the substance that we call the titrant, and in our case the titrant is our HCl. This is always the thing that this is the standard solution, so we know the concentration of this. And we are going to slowly add that to our sample or analyte. And in this case, what we want to analyze is our sodium hydroxide sample. So we know the volume of this, okay, because we added it in there. What we want to do in this experiment is we want to determine how much of the titrant we're going to need to add to completely react the sample or the analyte. So how much HCl do I need to neutralize the sodium hydroxide? So, you know, something's missing here. What we're going to need to do here is we're going to use a little trick. We're going to use a acid-base indicator. And we're going to put that in our Erlenmeyer flask with our analyte. And that's going to tell us when the HCl and the sodium hydroxide are at equivalent amounts. When I have an equivalent amount of acid, strong acid and strong base, I'm going to reach a pH of 7. I'm going to be neutral. And so I'm going to put a pH indicator in there that is going to have a color change at a neutral pH. So the one that we chose for our lab was bromothymol blue. So we're going to throw a little indicator in here. And it's bromothymol blue. So we got to throw a little indicator in there. That's going to tell us when we've added enough titrant to our analyte to neutralize it. So when we do this experiment, we're going to look at a couple of different little things here that we need to have in order to do our titration. So the first thing is reading your burette. So I'm going to be recording some initial readings and some final readings. So this would be for, let's say, my first trial. I'm going to do a number of different trials to make sure I have a good sample size for my data. So what I'm going to do here is I'm going to look for the meniscus. Now we see we have a concave meniscus shaped like this. Oops. And what I'm going to look for is, that didn't work out that well. What I'm going to look for is the very bottom of the meniscus. What reading is that? And I'm actually going to also estimate one extra decimal point to this. So this burette is calibrated to tenths of a milliliter. I'm going to add an extra decimal place to hundredths of a milliliter. So I would say it's pretty close to right on that line. So that's going to be 0.10. So I'm going to say 0.10. Okay. Now there's a data table down here. So this would be the data table that I could read my or record my data on. So before I start my titration, I'm going to record that value right here. Okay, so I'm going to now do my titration. So once I added my bromothiamyl blue to my base, bromothiamyl blue is an indicator that is going to turn from yellow to blue, and it's a pH of, I hope I get this right, 6 to 7.6. So if I put a bromothiamyl blue in a strong base, it's going to be blue. So that's what's gonna happen. Now at pH 7, it's gonna be between yellow and blue. It's gonna be green. So green is gonna be what we're gonna look for as our end point when we're going to stop our titration. If I add too much acid and my solution becomes acidic, then my solution would become yellow. If it went below a pH of 6, it would become yellow. So what I'm gonna have here is I'm going to have a blue solution in the bottom here. So let's just use this. Okay, so it's blue. I start adding titrant. I open up the valve or the stopcock. I start adding titrant in, and I see that I get to a point where my solution turns green. That's perfect. It turned green. That's when I want to stop. That's what I would call the end point of my titration. Now, if I add a little bit too much, then my solution would become yellow, and so that would be what I would call an overshoot in my titration. So your first trial is usually just a practice one. A lot of time you're going to have an overshoot in your first run, and so if I was to then measure my final volume that I added for my first trial, I'm going to say, what did I say here? I said that we have 18.56 here. So there's 18, there's 18.5. Here would be 18.56. And you notice that the graduations on the burette actually go from, they go down instead of, as you go from top to bottom, they go down. So that's because we're letting out liquid out of the bottom of this burette. So I'm gonna then record that value. So there's my 18.56. Now to figure out how much HCl was added, I'm just gonna subtract those, and I'm gonna get this value right here. So what my goal is I want to do a number of different trials, and I want to get it so that I have 3 trials within 0.2 milliliters of one another. So I've just made up some data here. So I did, my trial 2, trial 3, trial 4, I did them perfectly. I got to my nice green endpoint. And I'm going to take those numbers then, and I'm going to average them. So I'm going to take these 3 numbers right here, my 16.8, 16.82, 16.84. I'm going to add those together. I'm going to divide by 3, and I'm going to get 16.82 for my average volume of HCl added. So now I know my missing value, my missing volume. So I can solve my problem. So I'm going to bring that back up here. This volume right here was 16 point. Now I forgot that. All right, 16.82 milliliters, and we'll change that to liters. 0.01682 liters. So now I have enough information. I've experimentally found that volume. Now I have enough information to solve for my missing concentration. So I'm just going to solve this like any other solution stoichiometry. So here's my given, here's my required. So my given, I'm going to start with this volume that I just came up with, 0.01682 liters of my HCl. I'm going to turn that into moles. There's 0.50 moles in each liter of that HCl. I'm going to jump from HCl over to sodium hydroxide. It's a 1-to-1 ratio here. Okay, and now I want to get concentration, so I'm going to take those moles and I'm going to carry those moles over by just putting this placeholder here, this 1, and I'm going to divide those moles by the volume of sodium hydroxide that I'm reacting, and that was my 10 milliliters, so 0.01 liters. So take out my trusty calculator here, and I'm going to take my 0.01682. I'm going to multiply that by 0.5. Okay, that's my concentration. I don't need to do the 1/1, and then I'm going to divide by, so I'm going to do it like this. I'm going to multiply by 1 over my volume of sodium hydroxide, 0.01. That's 10 milliliters. And I get this answer, 0.841. So that turns out to be the concentration of my sodium hydroxide in this experiment. And I guess, should I have proper, I guess it's one, I mean, it's 1 sig dig here. So, you know, I guess 0.8 moles per liter would be a more proper answer for my concentration of sodium hydroxide. And that's it. I'll make another quick video looking at a titration curve, but I mean, that's it. So we're experimentally finding that missing volume, doing a titration so that we can solve it using a stoichiometric equation. Okay, hope that helps, guys.